focus on is something called completing the square. And if I had to say what one of my least favorite things about math was, it would be this: complete the square. I don't like it. So we're all allowed, right, to have something that we don't like. The other one that I don't like is teaching polynomial long division because it's really, really boring. So now you know. Now you know what I don't like about math. It's this. So complete the square is important. And that's why I am going to teach it to you, because if I'm looking at an equation in standard form, which we've talked about a lot, I can't see the vertex just by doing this. And we've talked about saying, like, you can do the x equals negative b over 2a, and you get the x value of the vertex, and then you can plug it in. There is just a method called completing the square that puts standard form into vertex form. So the purpose of complete the square is to change from standard to vertex, and then you can easily see the vertex. So what I've kind of started out with is these like fill in the blanks, where we talked last unit a lot about these perfect squares, and they were trinomials or binomials, the difference of perfect squares and perfect square trinomials and binomials. So when I'm looking at this and I'm saying x squared plus 10x plus something equals x plus 5 squared, these aren't too tricky if you remember that pattern. If you also use this idea here, this b over 2a idea, you think about like what, like half of 10 is 5, you know, and there's no a here. So 10 divided by 2 is 5. 10 divided by 2, I'm going to write it here. 10 divided by 2 equals 5. And then if I square 5 and put it here, I get 25. And so 25 squared, and even if this was negative, right, negative b over 2a, and it was negative 5, I'd square it and I'd still get 25. This would be the factored version of it, and this would be the FOILed or expanded version of it. Okay, so what's different when I have a negative here? Well, this is negative. So still half of 8 is 4, and 4 squared is 16. And that number is positive in both of these instances because this would be minus 4 is negative 8, and negative 4 times negative 4 is positive 16. So just, we need to be careful of that sign here. So then this is kind of like what we did. Well, this is that perfect square trinomial, right? Half of 6 is 3. 3 squared is 9. So what number goes here is that 3. Okay. Half of 12 is 6. 6 squared is 36. So that number goes here. In this one, I'm asking you to do both things. Well, put the x. So what is half of 18? Is 9. 9 and square it is 81. And then the 9 is going to go here too. So if you need more practice with these, just thinking about what are those perfect square numbers. And those perfect square numbers are going to be like 2 squared is 4, 3 squared is 9, 16, 25, 36. You guys know these. You could also just type in a tab right now, perfect squares, and you would get an entire list of these. So if you're struggling with this pattern, you should pause on the next slide, which I think I have another example, and practice these. Okay, so if you are struggling, you practice. If this was too easy, then move on a little bit. What happens now is these aren't perfect square trinomials. You will notice that I don't have something on the left and something on the right, and I need to now take this equation that's in standard form and write it in vertex form. Okay? Now, this means you're going to change from standard to vertex, and how we do that is I'm going to complete the square. One of Miss Vote's least favorite things, complete the square. Okay? I'm going to replace f of x with 0 for now. Remember, this just means function. This is function notation. Okay, function notation. 0 equals x squared minus 8x plus 11. And so if you recall back to that previous slide, if you need to pause and rewind, all of them had something like this, x squared minus 8x, and then they had like a blank right here, right? And I need to kind of get to that. So to get to that, I kind of need to get rid of the 11. And in math, we don't just get rid of things, but we can use algebra to move things to other sides. So right now I have negative 11 equals x squared minus 8x. And I'm going to put that blank here. Okay, and just like when I subtracted negative 11 to get rid of it and I had to put it on the other side, whatever blank I put on the right side, I have to put on the left side. And here's the thing I always forget, so I do it right away. Okay, so whatever I'm going to plop onto this right side of my equation, I also have to plop onto the left side of the equation. So now I can do that thing that we were practicing on this first slide, and maybe you practiced again on the second slide, was dividing this. And so remember, I've got my little reminder here that x is the negative. Okay, well, half of this is negative 4, right? And negative 4 squared is positive 16. If I add positive 16 to the right side, I have to add positive 16 to the left side. Okay, how does this help me? Miss Vogt, this doesn't make any sense. Nothing is happening right now. You're right, nothing is happening right now. But we completed the square. This is your action right here, completing the square. We made a perfect square trinomial. How can I factor this? This will be x minus 4 squared. That was that skill we were practicing on slides 1 and 2. If you're stuck, back up and try again. Okay, go back to that slide 2 and practice completing the square and quickly factoring these. Seeing the pattern, this is x minus 4 squared. And on this side, what do I have left? I have 5 left. We are still not in vertex form. I need to move this number back over. And I'm going to replace y. F of x would be a good 2. I used y, but to stay consistent, maybe I should have used f of x. X minus 4 squared minus 5. This should look familiar. We are now in vertex form. And what I did to check my work, you guys know I make tons of mistakes, is I went on Desmos and typed this in, the original. And then I looked and I said, is the vertex 4 comma negative 5? So remember the vertex is at 4, negative 5. And it was. Okay, when I drew this, when I graphed it on Desmos, it was at 4, negative 5. I know I did it right. Okay, when we take the test on this, you won't be checking your work with Desmos. You're going to trust yourself. For now, I don't trust myself yet. I'm going to practice. Okay, I have another one to show you. Okay, we're going to do the same thing. Write the equation in vertex form. That means we're going to move from standard to vertex using complete the square. Okay, so first thing to do is I'm going to replace g of x currently with a 0 just so that I can work on this from both sides. And to get my first couple things by themselves, I need to subtract 68 from both sides. So on this side, I have negative 68 equals x squared plus 26x. And this is where I need to complete that action of completing the square. So I put it on both sides so that I remember to balance the right and the left. And I don't forget when I add something to the right that I have to add it to the left too. So I need to take this and divide it in half. And then I need to square it. Okay, you will notice we're getting into some big numbers. These aren't always as pretty as we'd like them to be. Okay, then I need to quickly factor. Oh, see, that thing I forget. Good thing I drew a blank. I need to add my perfect square to both sides. Then I'm going to factor. This is x plus 13 squared. And when I add 169 and negative 68, I get positive 101. Now I need to move it back. Need to subtract 101 from both sides to get it over to here. And now, because we don't trust Mrs. Vogt or ourselves, we're going to go on to Desmos and try it out. And you should see that the vertex is -13, -101. And I checked before I made this video because I was worried about making mistakes and looking silly online, even though I do that anyways. And I did get that one right. Okay, so this is a tricky process. And when we move into completing the square where a does not equal 1, this gets even harder. So please, guys, make sure that you are sending me a Google chat if you have some trouble. I set up another meeting for us on Thursday at 10 a.m. It was really fun last time. We all got to talk to each other, but I would totally also help you. Or, if you want to set up a meeting with me, I can send you a link and we can just work on homework together if that's the kind of help you need. I miss you guys a ton. I hope I get to talk to you guys on a video chat or a hangout really, really soon. Let me know if you have questions.